All right, we'll go ahead and get started. Um, Things I want to do today. I want to go over, I just want to quickly review this because we've reviewed this a bunch of times. Besides that, I want to go over questions on the homework, which it didn't seem like there were many. I looked over them just before class, at least the people who did turn it in already. And they looked really good. In fact, people were doing some things that I didn't really expect them to. Uh, and it was just a clever use of square roots. So that was good to see. Okay. Um, I don't want to spend too much time on this. Everything you have on your screen, you've seen, I think, 2 or 3 times just from different lectures. Okay, so you probably already have this in your notes, but this is everything that we've been working on this chapter. Okay, SOHCAHTOA, reciprocal functions, Pythagorean theorem, just labeling sides of a triangle, inverse trig, and then with all of that, just rationalizing fractions and square roots, which we worked on a lot last night. Okay, um, all of this we should know. Probably the trickiest part here, or at least sometimes the most confusing part, was rationalizing fractions and just dealing with square roots. Okay, but it seems like people are starting to get it. And if they aren't starting to get it, they're at least decently close. Okay, so I want to just address a couple of questions that I saw here. Um, so one of the questions says, just how do I know when I can simplify a square root and when should I not? Okay, when you simplify square roots, so say we have the square root of 27. Okay, you can only simplify square roots if you can factor out a perfect square from the thing underneath. Okay, so if you can split 27 into a perfect square times something else, then you can simplify. Okay, which we can do, right? We can rewrite the square root of 27 as the square root of 3 times the square root of 9. And then we can simplify that square root of 9. That's just 3. The square root of 3 is remaining. So this ends up being 3 rad 3. Okay, so it's all about factoring. If you can factor really really well, this really isn't that difficult. I get that it can be confusing sometimes, especially as you get up into higher numbers, which sometimes worksheets and IXLs do. Um, but that's really good practice. And if you struggle with those, that's okay. It's This is purely about experience at this point. Um, and the more you do some of these numbers, the more things you realize, the more tricks you learn, uh, and just the more factors you know. Okay. Besides that, it didn't look like there were many questions. Um, well, the other one, just quickly, and we've gone over this a couple of times. Whenever you multiply a square root by itself, that just becomes the thing underneath. Right? They kind of combine and they cancel out the square root. Uh, if you know if you know that rule, that's fine. What's really happening here is that you have the square of the square root of something, and you'll find out next year. You can actually rewrite, and again, you don't have to know this. So if you want to stop listening to me right now, that's for this example. That's totally fine. Um, the square root of a is really a to the 1/2, and when you have a to the 1/2 squared, this exponent and this exponent come together, and it just becomes a to the first. Again, you do not have to know that right now, but that's what's actually happening. I'm not going to expect you to rewrite that or use that in any way, shape, or form, but that is how that works. Okay, so that honestly, it looks like all of the questions. And if you have more, um, or you just hadn't turned it in just yet, which ideally you should have. And as a reminder, if you haven't, you need to submit it to on campus. Okay, please do not email me them. I want to keep them all in the same place. I want to have them all where I can find them very easily and where I can grade them really easy. I don't want to have to go searching through my email. All right. But that looks like all the questions. It looks like you guys did all right with it, or at least the people who did it. Okay. So let's jump back to what we're doing today. Okay. So we reviewed, we went over a couple questions on the homework. And everything we've done so far is revolved around right triangles. So everything on here, everything that you see on your screen right now, except for maybe this stuff in pink, it really only applies to triangles that have a right angle inside of it. The Pythagorean theorem, SOHCAHTOA, the reciprocal functions, even inverse trig to an extent, all of that only has to do with right triangles. Okay, what we're going to do today is we're going to get into triangles that are not right triangles. Okay, so that brings us to this. So what if triangles don't have a right triangle? Well, if they aren't, then we can get this kind of pattern, which is called the law of sines. And what this says is that if we do not have a right triangle, or really even if you do have a right triangle, I think this works for everything, you can kind of cut up the triangle as angles and their opposites. Right, so this vertex A, this angle A, and its opposite side is A, this angle B, capital B, and its opposite side, lowercase b, and this angle C, and its opposite side, lowercase c. Okay, we can split up this triangle into a ratio where you take the sine of A over the side length of A is equal to the sine of angle B over the side length of B, and the sine of angle C over the length C. Okay, so I'll give people a second to write that down. This is going to be really helpful to have in front of you. Okay, so like I'll copy and paste it onto every example that we do, but this is brand new. It's something that you haven't seen before, so the more you have this in front of you, the better. And this is what your homework will be on. But I'll give people a second to write this down, and then we'll go over examples. All right, so this is pretty much exactly what your homework is going to look like. There aren't too many variations in this. The only like true variation that there would be is that the angles that we're dealing with are 30, 45, or 60, in which case you'd have to use those special values. All right, but for this, I think this is in like the 75 range on your homework. Okay, you're given a triangle, you're given a couple of angles, and you're given a couple of sides that are labeled, and you want to solve for a specific side. And this V should be 12. All right, so in order to solve for t, I'm going to kind of break this down kind of like I did in right triangle trig. Okay, I'm going to just label the sides so we know what's what. And they should be labeled for you. They're already kind of labeled here, kind of like I did up above. But I want to make it kind of explicit so we see. All right, so this 123-degree angle, angle T, belongs to this side. This angle U is the opposite of this side U. And then this angle V is opposite that side V. Okay, so first thing, again, just label the sides, be pretty explicit about it. Then we can kind of set up a ratio, but even before that, if you're ever given two angles of a triangle, so we're given angle T and angle U, just find this third angle just in case. All right, so we know that angle T plus angle U plus angle V, we know that has to be equal to 180. So 123 plus 30 plus angle V is equal to 180, and then we can solve for angle V. All right, so that's a pretty basic step. But are there any questions about what I just did? All right, then we can set up this ratio. Okay, so we know we are trying to find T. And actually, I'll just set up the entire ratio. So the sine of angle T over T is equal to the sine of V over V is equal to the sine of U over U. And then we can substitute in things that we know. So I'm going to make this just a little bit smaller so I can see. Okay, so we have that the sine of 123 divided by t is equal to the sine of 27 divided by 12, which is also equal to the sine of 30 over u. Okay, so that's everything we know about this triangle. And we're trying to solve for t. So the only unknown that we should have in our function, in our expression, is that angle t. Okay, so with that in mind, we can get rid of anything and everything that has another unknown in it. Okay, so red is totally filled out. All right, so we can keep that. Green, though, is not, so we should get rid of it. And then we have that the sine of 123 over t is equal to the sine of 27 over 12. And we have to solve for t. And again, this just requires a little bit of algebra. So if we multiply by t on both sides, we get sine of 123 is equal to t times sine of 27 divided by 12. Again, we got to get t by itself, so I'd multiply by 12. And then finally divide by sine of 27. And then we get t by itself. We have t is equal to 12 times sine of 123 divided by sine of 27. Okay, we'd plug that into a calculator, get an answer. These directions say to write your answer as an integer or as a decimal rounded to the nearest tenth. Okay, so when we plug this into a calculator, again, I would put parentheses around both the numerator and the denominator. So in your calculator, I would type it in as exactly as this. Okay, so I'll pull up Desmos here. And again, we're dealing with degrees, so the first thing we should do is change our mode. So we have 12 times sine of 123 divided by sine of 27. And we get 22.167, so our answer is 22.2. Could you cross multiply here? Yeah. Again, I like to do it step by step. If you want to cross multiply, that's totally fine. Just do it carefully. Usually when people say, oh, you just cross multiply, they don't really know what's happening. I like to show it step by step so people actually do understand what's happening. But yes, you can cross multiply. And we can do one or two more examples. But I want to stop there for a second. Are there any questions over this problem? Okay, on this next example, again, this is directly from the homework. This is actually the first problem. So we did a harder problem up above. I think they're all actually about the same. Um, I think it just depends on what you're solving for. All right. So in this, it says find f given this diagram. And if you can't see this, we have an angle of 19 degrees, we have an angle of 34 degrees, and we have a side length of 14. The first thing that I'm going to do is just label my sides, or at least organize them a little bit. So this angle G goes with 14. This angle 19 goes with F. And this angle E goes with E. Could you use a protractor to find the answer of F, or am I, well, so we're trying to find the side length of F. And even if you could do that, like, that's not necessarily exact. Okay, so an exact answer is something that's achieved through this process, because you could be just slight, millimeters off or fractions of a millimeter off, which isn't necessarily exact. Okay, so you could use a protractor to find an angle, but in this you could not use a protractor to find side lengths. Okay, so given f, or we want to find f in this case, and again we can just kind of set up our equation, right? So sine of g over the side length of g is equal to sine of f over f is equal to sine of e over e. Okay, so that is just the law of sines. That's all I wrote. If you know that process, you're like halfway there. Okay, then we just substitute in what we know and see what we actually need. So the sine of g, so sine of 34 over 14 is equal to the sine of 19 over f. And then we have two unknowns. All we really want is f, so that should be the only unknown that we have. So we can cross out this part, and we're done with that. Does the order matter for this, for that? So like you can have sine of f over f is equal to sine of g over g is equal to sine of e over e. As long as you have that rule, you're fine. Now numerator order does matter. So the signs always have to be on top. The denominators always have to be the side lengths. And only opposite sides go with each other. Okay, that's why I make it kind of a big deal up front to draw these lines, just so I know for sure. Right, so sine of 34 has to go with sine of 14. Or sine of 34 has to go with side length 14. Sine of 19 has to go with side length of f. Sine of e has to go with e. But you can write them in different orders. Okay, so then we have something we can solve for. We have sine of 34 over 14 is equal to sine of 19 over f. And again, you can cross multiply here. When you do that, you get f times sine of 34 is equal to 14 sine of 19. We want to get f by itself, so we have to divide by sine of 34. When we do that, we get f is equal to 14 sine of 19 divided by sine of 34. And then we have our expression that we can then type into a calculator. Okay, so if you get here, like on a test or a quiz or anything like that, if I guess if we were in like a traditional setting right now, which we're not, that would be like 90% of the credit. Okay, the rest would be kind of typing it in. Okay, so if we do that, again, I'll pull up Desmos. We have that f is equal to 14 times sine of 19 divided by sine of 34. So we get 8.1509. This problem says to round to the nearest tenth. So our answer is 8.2. Questions about that problem? Questions about anything I just did? Is Desmos easier to use? So there, kind of, it's easier to type in stuff so that you can actually type it in as we write it. But at the same time, it's best that you get to know your TI-84 or TI-83 because you're not going to have a computer with Desmos on it when you go into the ACT, when you go into any standardized test, any test in college. Like, you will have a TI-83 or TI-84. Okay. Yes, you can use Desmos for this. It's great. It does exactly what we need it to. But it's not legal on actual tests. So the better you're able to use your calculator, your TI-83 or TI-84, the better. And I wrote this on Desmos like I would type it into a calculator. So you would do 14, like parentheses, 14 times sine of 19, close parentheses, divided by open parentheses, sine of 34, close parentheses. I typed in it again exactly as I would into a calculator. And again, the more comfortable you are with the TI-84, the better. Okay. I'm gonna do one more example. If you guys feel 100% comfortable with this, feel free to go to Teams. I'll be in there in the next couple of minutes. But if you feel like you need one more example, go ahead and stay here. Actually, yeah, I'll do one more example here, and then I'll head over to Teams. I'll do it really quickly, and then I'll be on Teams to help people kind of individually. Again, I strongly suggest actually being on Teams. So if people do have questions that you're unsure about, I can kind of answer them all in one fell swoop. Okay. So the next example. Gives us this, and we're trying to solve for u. Again, I'm just going to label all my sides. So 80 goes with 16. 41 goes with u. And the v's go together. So we can set up our equation. So sine of 80 divided by 16 is equal to sine of 41 over u, and then sine of v over v. Again, we're trying to solve for u, so this u should be the only unknown that we have. So we can get rid of this sine of v over v and then solve for u. When we cross multiply, we get u times sine of 80 is equal to 16 sine of 41 divide by sine of 80 on both sides. We get u is equal to 16 sine of 41 over sine of 80. Can plug that into a calculator and get an answer. She should get 10.7. Questions on this example? I'll leave this open for the next minute or so. After that, I will start a meeting on Teams, and I can help people out kind of on a more like concrete basis. Okay. So general questions here, and then if you need help on certain questions, I will help you in Teams. Oh yeah, your homework. Your homework is R11. Yes, that's due Monday. I'm not sure what you mean by why, but I will answer that in Teams if you want to. Okay, so I'll close this, and I'll start a meeting in Teams here in the next minute or so.